So hello and welcome to this third session, and it'll be a few more minutes. So while we're waiting, I just wanted to ask, does anyone have any specific circuit you want to simulate or any specific topic that you want to investigate?
Hello, sir. Hello.
Hello.
So you said this is a third session. So is it a third or it's a starting session?
No, this happens every week. So the first week we just did like a basic introduction to how we can use Python for power electronics. Last week there was a student who already uses Python power electronics. He wanted to know how we can calculate the RMS of an inverter output, that is inverter switched output voltage, using Python. So we did that. So the YouTube lectures you can find, of course, I don't know, are you part of the Google group or are we connected on LinkedIn?
I enrolled for the 14th of July, but the mail had come that it is being postponed to 28th of July. So I didn't attend the previous two sessions. I just got the mail of today.
Okay. 14th of July.
Yeah.
No, that wasn't postponed. It was there. 14th of July we had it.
No, so first mail was that I have enrolled. Second mail I got that it is being postponed to 28th of July.
Oh my god. Okay, then you know what? That was a bug. What it means, what happens is that after every session, I create another event. So for example, after last week's session, I create another event so that students who are registered can now continue for the next one.
Okay.
So then there was a bug in the system, because that doesn't mean it was postponed. It should have said that the next session is on 28th. You are already registered.
Yeah.
Hi, Nikhil. Okay, so we have a few others.
Few of my friends are also joining.
Sure. Yeah, I got an email from several other people saying they want to use Python power electronics. I just gave them this link. I don't know if they will come. So
actually, one of my friends has done something. He has some doubts, so he was sharing. He said he will be sharing today.
Oh, sure.
Sir, so I don't have that Python power electronics kind of software. So from where should I download it?
Oh, okay. So the only thing is, like, I usually post my LinkedIn. I can just what I'm going to do, I'm going to share my screen and I'll show you where it is. So so you should start seeing my screen. So what you have to do is just go to YouTube and on YouTube search for Python power electronics. So this is my own YouTube channel where I post a lot of videos. So I have created a new playlist. So this playlist is the Learn Power Electronics online session. Actually, I'll just go back. View full playlist. So there have been two. So the session 1, session 2. Session 1, I installed Python power electronics. So you can see both of them. Last week we solved the RMS problem. The first one we just installed Python power electronics. So you can check out. So all you have to do is go to YouTube, search for Python power electronics, and you can check out this Learn Power Electronics online playlist.
Thank you.
Yeah. So other than that, the YouTube channel contains a lot of other things. I have an ongoing DC to DC converter lecture series if you are into DC to DC converters. Otherwise, there are several other playlists. There is a UPS playlist, UPS video lectures. So whatever you want. Okay, so it's now 6 p.m. I guess if people would join soon, they can join. Otherwise, we can get started with anything we want. So, yeah. So, just to recap, the way we usually do this is that it is driven by you. Since we have a couple of new joinees, I'll just give a brief background that this is typically a place I will not be teaching. This is not like a tutorial session. This is more like a sharing session where those who want to simulate power electronics with Python come with their doubts and we can all get together and solve them. That's how it is. So one is, if I have several courses on Udemy, if you have taken those courses, you can check it out. I am also an instructor on Udemy. I have courses on basic simulation of power electronics. I have a course on digital signal processing, and I have also a course on simulating transformers using Python. So if you're doing these courses and you have any doubts, you can come and ask them here and ask for help. If you have your own projects, could be a bachelor's project, master's projects, anything, and you need help, you can come here and we'll try to help you. So this is basically problems that you have that you want to solve and you want help on that. That's essentially how it is. So anyone is welcome to bring problems, and we usually spend time just solving them. So this is how usually these lecture series, or rather these sessions, are held. So yeah, so I'll just leave it open. I think Nikhil, you were saying something. You can get started if you want.
Fabian, who was actually left now, he wanted to share something. So I don't know what is happening. Till he returns, I will show you something which I have been doing, but because of some problem, output is not coming as expected. Fabian, are you there?
I think he has some issue with his mic because he's unmuted but nobody can hear him.
He's using different laptop today. Okay. So till he is ready, I will share my screen.
By the way, for those of you who are using this, try to use it on Google Chrome or something. I had issues with Firefox, and also when you come to this video chat, the pop-up will come saying that you must give permission to your microphone, you must give permission to your camera. So you can just text message him that this is there and it should come. So if he's using something like Explorer or Edge, I can't guarantee that these things may come.
Maybe if facing any issues, so I will share my screen.
Yeah. Hey Darius, we just got started.
Go on.
So I just was saying we have a few people online, and we have a couple of people who wanted to share, but they for some reason can't speak. So the only thing I was suggesting to them is they could use something like Google Chrome. If they're using like Microsoft Edge or something like that and that's giving them an issue, then they should try to use something like Google Chrome instead, which can allow them, because it will also, the pop-up needs to come that the API needs to use the camera and also the microphone. So I think maybe that's that pop-ups not coming, particularly some windows, some explorers may have suppressed it, pop-ups. There may be a pop-up suppressor. So we might...
Okay, so can I just quickly go through the list of participants here and they can tell me who's having problems? So
yeah, go ahead.
Niraj, are you one of the people? Okay, so they can't talk, right? So it doesn't...
Neeraj, I believe, can talk. I think it's Fabian.
Yeah, I can talk.
Yeah.
I can talk.
Okay, do you have do you have any problem with screen share or video or anything?
No.
Okay.
I'm fine. I'm running on Firefox only, and it's running better.
Beautiful. Okay, and Hari Krishna. Is Hari Krishna having a difficult time? Okay. Fabian.
He is, I believe, having a tough time.
Okay. And so Fabian, use Chrome if you can, and I'll send you. I'm gonna send a link to the participants in this group, and then we will. I'll ask you to run a network test. Okay, the network test will stay in your browser. If you don't download anything, you just run it in your browser, and it'll say, okay, what are the problems? Anne, can you hear us, Anne? Hi, Anne, can you hear us?
Yes, I can.
Okay, excellent.
Hi.
Okay. So it looks like Hari Krishna. What about Fabian?
Fabian is struggling, I believe.
His browser actually is texting me here, but I think there is a problem with his browser.
With Fabian's browser.
I think you should also ask him, go to the settings of the browser, and if he has a pop-up suppressor, he should uncheck that, because that will come as a pop-up that the browser needs access to the microphone and the camera. Okay.
So
Okay.
every session will be uploaded to YouTube?
Yes, every session is recorded and uploaded.
Okay, thank you.
Okay, so I guess Neeraj, you can share in the meantime. If Fabian can join again, then we can talk about what he's doing.
Yeah.
So Fabian is your friend?
Yeah. Okay. So he is my friend.
Okay, cool. And then we have Hari Krishna. Okay, hi. But we can see you, but we can't hear you.
Yeah.
Okay, he can hear us.
Okay.
He can hear us. Okay, so I'll send you a link, Hari Krishna, and then we can troubleshoot. We can't hear you, brother. Can't hear you.
All right.
Okay. So take it away, Shiv.
Okay, so yeah, Nikhil, go ahead, share. We can talk about he has something that he wants to share, so.
Can you see the screen?
Yeah.
So this is the output of my 3-phase inverter voltage output. So it is not coming as it is expected. So I will share you my circuit so that you can check whether what's the problem. This is the circuit.
Which one we have? Okay, 3-phase. Okay, 3-leg, single DC source. Okay.
And these jump commands are given for filter 1, filter 2, filter, because it is connected to the filter file, which is the next.
Yep.
Next.
Okay.
Filter. Basically, these are the connections, and here what I have done is
Okay.
Here is a capacitor.
Mhm.
Here is an inductor somewhere. Here is the inductor.
Mhm.
Inductor. And these are the capacitors.
Mhm.
Capacitors. Okay. And here I have connected in a star connection.
Mhm.
And here again jump connections are given for the third file, which is the load.
Mhm.
Okay. Load is this. This is the load.
Mhm.
So is there anything wrong here?
No, it seems okay. Let's do. It seems like a delta connected load. So first thing, can we look at the parameters of this circuit? Just make sure that they are all balanced to begin with, and then once that is done, we'll look at the control code.
The parameter of three-phase inverter first.
Parameter of 3 phase. Yeah, we can start with that. Yeah, Haripur, you're asking something, but I don't think we can hear you. Okay. Can you expand the DEFG column? Voltage level is the same. Okay. We have, okay, switches 7F, 7L, 19, 20, 20. Okay, so the main thing is all the switches are pointing downwards. That's good. Name of the switches S1, S3, S5, S2, S4, S6. Yeah, they are also matching. The next thing is the diode. Diode is 7H, 6H, 7N, 6N, 70, 80, 19, 18. You see the last diode is wrong. Diode D6 inverter 1, 19T, cathode polarity is 20. It should be 18.
Should be
18 because all the diodes have to be pointing upwards. These are anti-parallel diodes.
yeah. Okay.
So that one diode will not conduct. Or rather the diode will conduct all the time because you have a DC voltage. It will be forward bias.
Which diode is
Diode 6.
So this is position.
Hmm.
Yes, so it should point upwards.
Yeah.
So it should be 18. Okay. And D4 should also be 18. Right?
The rest are okay. Only D6. Check out D6. See. No, that is okay. That is the first one is the position of the diode. The last, look at the column E, cathode polarity.
Sorry.
Okay. So yeah, you can just.
Other than that?
Well, one, since we made this and it is a big change, what I would suggest is you upload this file and run the simulation again. So you know what to do, right? When you go to the edit circuit parameters, I mean, you probably will have to save simulation parameters, I think. Yeah.
No, actually I was trying to change the name of that file.
Okay.
Create a new one, but okay. So now we have to
Edit in the edit circuit parameters because you have to go to parameters, right? No, not control, parameters, because you have changed the circuit parameters. So you have to upload the new parameter file. So basically you have to take 3-phase inverter, whichever is the file that you have changed the parameter to.
Yeah, parameter files will be updated.
Yeah. So you just browse
Yeah,
and
it is not changed.
yeah, because this is the database.
Not changed.
Yeah, this is the database.
Okay.
So one, you can change it manually or you can upload the new one, whichever is okay.
Only one change, so we can change it.
Yeah, you can here also by hand, you can do it. Is that one?
Right?
Yeah.
Should be 18.
Yeah. Okay.
Everything was and LC filter file you saw it was correct according to you?
The LC filter, I mean, usually what I would suggest is whenever you make change, at least some change like this, run the simulation once to see the effect. I think we've lost Neeraj. Okay, you're back. Yeah, we lost you for a while. We see your screen now. Oh, we've lost Neeraj. Oh, we've lost Nikhil actually, not Neeraj. We've lost Nikhil.
Hopefully he'll join.
Yeah, I guess it is night time in India, so I guess a lot of people will be online. It's actually must be night time in India, so a lot of people will be online.
It is raining here, so that's why there was some problem with internet.
Okay, yeah, continue. Yeah, we edited.
About that LC filter.
Yeah, so basically the way it works is when you make any major change, it is always a good idea to run it once because then you can see what is the effect of that change. Okay. So we can still do, but from a perspective of debugging, this is how you debug any simulation or any software. When you make a change, run it. And you can, best thing is that way if you save the files, then you will also know, like the simulation files, you will also, or rather even the simulation results, you will also know what is the impact of each change. Yeah. So you can run.
So now?
No, you have to run once.
I just want to say really quickly that I just sent an email to Hari Krishna and Fabian to run the test. So you can run that. I sent you an email, so just check that. And then if you have any other problems, we can set up a call, and I'll do a troubleshoot with you in your browser.
Okay.
I'll do a troubleshoot with you on a Zoom call or something.
Okay, now one thing is, it is working, but whenever you click on the run button, always check your command line to see if there's an error in your, because what happens is, particularly when you have control files can always give some error, because even if there's a syntax error or something, it will appear in the command line. But anyway, since it's working, no problem. Yeah, you will have to plot actually several times because it may take a minute or so before you get at least one waveform, one cycle. Yeah, it will take at least, I think, 1 minute because this is a 3-phase system, right? Yeah. Okay.
And one more thing I wanted to ask, whether like in MATLAB we have different type of solvers, okay? So that some type of circuit works best with so and so solver. So is there any such provision made here, or are you trying to do it in further updates?
Okay, so the way it works is, the solver that I'm using is Runge-Kutta 4th order method. Now that is usually the best solver that you can think of. There is Runge-Kutta 5th order method also, but that becomes computationally intensive. So in terms of computational load and accuracy, Runge-Kutta 4th order is quite good. Now if you look at MATLAB and things like that, they have several solvers because they assume that your circuit can change in complexity. Now, in my case, I chose Runge-Kutta fourth order method specifically because I wanted this to be able to simulate large power electronic circuits. So this is specifically for that kind of thing. So do you need to change? I don't think I will add that feature because there is no need to produce that complexity, that you have to change, you have to check what simulator you need. The other thing about solving is I've used other simulators like Plex. I don't know, have you ever used Plex?
I have saw, but I have not used.
The Plex has a variable time step solver. There is no time step in Plex, if you've noticed. So the integration time step in Plex, you don't supply it. Now, what it does is it will compute the best possible integration time step that is needed. Now, that is okay if your circuit is small. Now, if you have a large circuit and it is complex, then sometimes the integration time step will go down so small that your simulation will freeze. I don't know if you've noticed, but it will freeze. Like there'll be one green dot on the plot because the simulation time step has gone down to like picoseconds or something even smaller. So which is why I do not use these two options. So these two options in most likelihood will not be provided in Python Power Electronics. So one is, it will always be Runge-Kutta fourth order method unless I feel that I need to move to something else, in which case it will always move. The other possibility is in terms of variable time step, I may put a warning that there is a convergence issue that I might have to work on, but that is a slightly complex problem. I will not solve it now. Maybe when I go to more complex circuits, I might try to tackle it.
So I don't think so it will be a stable yet, because
it will take. So in the meantime, if anybody else wants to talk, I'll be happy because we can come back after 5-10 minutes.
Yeah.
So, or you want to show something else, that's also okay. No, if nobody else wants to show, we can continue talking about your simulation. So I'll just ask anyone else if they have anything. Does anybody else want to discuss or? Hari, we cannot hear you. How about the others? Anyone has anything to say?
Actually, Fabian is saying that there is some issue with the browser, and with second browser also he is not able to hear from our side.
Oh, I see. I don't know how to solve that. Okay, so like I said, anyone has anything to say, or otherwise we can just keep looking at Nikhil's circuit. I just want to give everyone a chance to say something if anyone has anything. Unfortunately, we cannot hear Hari or Fabian, so there's only Anne. If Anne wants to say something, you're welcome to.
Hi, sir.
Hello.
Now, I have just started with the system, so I thought first I have to see all these things, first I have to understand everything. Just I have started installing Anaconda 5 PPE and all.
Mm-hmm.
So in later classes, if I am able to simulate the circuits, I will ask my doubts on that.
Okay, sure.
Introduce yourself and what project you have done so that you can suggest you something.
Okay. Myself, Anne. I'm doing my ME Masters in Faber Egnal. and right now I am on design and development of a drive for an electric vehicle. That is my project. So I have done MATLAB simulation on indirect field-oriented control method using sine PWM and space vector PWM. Right now I am trying to implement that in hardware setup. That is the project.
So I guess it's just, you can continue to share, Nikhil, and maybe we can look at something else if you want.
So there are some other plots also that I have configured. So
Yeah, sure. We can look at any of them.
among this, so that we can troubleshoot.
Yeah, no problem.
So there are modulation signal and this triangular wave and how they generate pulses. Okay, and this is voltage, this is output current, and these are the inductor filter currents, capacitor currents, just to see how the behavior of inductor capacitor. So that I have configured it.
You probably have to zoom in a little.
The green ones are pulses, and orange and blue is for carrier and modulation.
I would say it's even, you can zoom in between, let's say 0.014 and 0.016. No, actually you have to put like 0.014 because it's, oh, okay, that also, no, but I think it's maybe too much, just check. Okay. Anyway, you can plot as many times, no problem. Yeah, that's the thing. So if you look, it is tough to know, but I think the sine triangle is there. Okay. I mean, that's the thing. If you can zoom between only for 2 milliseconds, so like if you see 0.012 to 0.014, then we can check the actual sine triangle effect. So if you look, you see, right, as this blue line is increasing, the width is increasing of the green pulses. That's basically pulse width modulation. So the only thing only question I will ask is, what is the resolution of your sine triangle control file?
Control I will show.
Yeah, good. So you have I think you have what? 500 nanoseconds. That is good. So 500 nanoseconds, anything, I mean, if you are choosing something like 1 or 2 microseconds, it may be, see, the way it is, like your carrier frequency is 5000 hertz. So 5000 hertz means one cycle of your carrier waveform will be 200 microseconds. So with 200 microseconds and 500 nanoseconds, how much will it be? You are sampling 1000 times in each carrier waveform. And 1000 times is good enough resolution. That is how you should kind of judge how much you need. So for example, sometimes
There
when
is
you...
some criteria also. There is some criteria also to choose this step size.
Yeah, see the idea...
Depending upon your modulation.
Yeah, it actually depends. Basically, what it basically depends upon is the nature of your fundamental that can change within a particular, within that carrier waveform. So for example, our assumption is that during each triangle waveform of that we are choosing, we have our modulation signal is constant. Typically, that's how it works, right? So in this case, for a 5000, we have a 5000 hertz carrier waveform. We are choosing, I'm assuming it's a 50 hertz sine wave. So which means your carrier waveform is 100 times greater frequency than your fundamental. So there is a significant amount of resolution. So in one carrier waveform, your modulation signal is almost constant. So now that your modulation signal is constant, you have to be able to pick out the exact position at which the intersection happens. You are checking 1000 times in each carrier waveform cycle. So that means your accuracy is down to 1 by 1000 of a carrier waveform. So again, that is good enough resolution. But in general, for example, depending upon your frequency, this is how you should sort of calculate whether you are getting reasonable or not.
Basically, these three are modulating signals, 120 degree apart, phase shifted. And these are the switching corresponding to the modulation signal.
Yeah, that's all. Yeah, that is perfectly okay. You use the 4 by slope thing, okay? Calculate the slope. Yeah.
These are for output, whatever you want to see in the output. These are assigned. Sorry, these are the outputs which are being plotted. These are the output commands.
Okay.
These are going to do switching.
Only suggestion I can give is that when you have what do you call your variable, when you're plotting a variable, it is better that you give you give a prefix related to your file or your inverter. Like for example, you said plot, right? In the future, the reason is if you want to take this file later and add it to a bigger simulation, then it is much more compact. So for example, if you name this, instead of saying SPWM modulator, you call this inverter 1 modulator, or rather inverter 1 H-bridge modulator. Then it becomes very, specific. So now if you create, let's say, simulation with 5 inverters, then this can be transferred directly without any change. But that is later. When you are scaling up, you'll automatically find these tips. But
one more practical problem I have found out when first I had done for single phase. Then when it was successful, then I moved to 3 phase. So when I was basically I just copy pasted the circuits from first and modified it to 3 phase. Okay? And when I was modifying it and uploaded the files to PPE, and then I found that there was some resistor which is missing. Then again I had to clear some space and move the circuit, copy paste some cells in different 2 cells apart, and then introduce one resistor or inductor, whatever. So in that process, what happens? All the other components addresses are being changed in the Excel sheet. So that is not reflected in the parameters list.
yeah, that is.
Some modification. So that time I have to modify each and every parameter addresses for each and every component. So for this 3-phase also, it was a big of headache for me. So
That is the problem. The reason why I've done it is that sometimes if you automatically do it, right? Like for example, if I automatically push all the polarity by 1 or something like that, then it may produce an error which you cannot debug later. For example, suddenly a switch polarity may reverse. Now, you may not expect it because for all you know, the switch polarity may be like you are still expecting the same. So now this way at least you will get an error. You'll get an error message saying that this polarity does not exist. Then you have to go and change it. So this is better than having it silently fail and you won't know what is happening. That is what I wanted to do.
and even I asked some of my friends who are working in extensive in Excel, so I shared this problem with them. So one of my friend was able to sort of solve this issue by taking the address from different Excel sheets and casting it on that particular cell. But the problem was that you have used convention that first the row element will be there and then the column element will be there. But in Excel they are using first number will be the column number and then the second will be the row number. Like you are saying 1A, but in Excel they are using A1. Because of that is not able to take the exact which you have programmed in the software. So it is like swapping the rows and column address by default, which is used in Excel.
Okay. Let me see. I can do what I can do is, if that happens, I can put like a little message saying, do you want to transfer all your component polarities? That I can do. If the person says yes, then we can just shift everything.
It will be very helpful according to me, because even if the circuit has been built and it is foolproof, then every time it will be a modular. You will have to just take the Excel sheet and use in the file. But when you are building it from scratch, in that process it is very much of a headache when we are doing it from scratch. So I found it very hectic while I was doing it for the first time. So next time onwards, I kept in mind that you should keep some room for any additional elements if it might encounter in future and all. So now I have developed a habit, but when I was doing it for the first time, this was the major issue that I was facing.
Okay. Well, the way I usually do is I usually try to break up my circuits into smaller blocks. Like try to use, like for example, if you have only an H bridge, put the H bridge separately, things like that. That way your components per circuit, per sheet are much smaller. So that for example, if let's say like what some people do is they connect everything together in one, which is actually a little messy. Whereas if you have an H bridge, you can put just the H bridge, then put the DC supply externally, put the filter separately, put the load separately. You've done that already in the UPS. But when you do that, then the error chances are much lesser. And you can use the modules again and again. That's also another advantage.
So if you could just do this much now, then it will be very convenient to new users as well as to the experienced users as well. Because even if we want one column additional, we have to move the entire right hand side of the circuit to one or two cells apart. So whatever components are there in the later part, every cell's position is changing. So we have to manually change each and everything. That is the big issue, according to me, what I have faced till now.
One other thing you can do is, unless of course this may not work, but let's say for example you want to add, let's say 2 columns to add maybe some components or something, resistor, ammeter or something. Now instead of inserting the resistor ammeter in that column, you can add a jump label instead. So put 2 jump labels and then externally just connect the jump labels in whatever you want. So even if you want to connect 4 or 5 components, you can just, even if you have let's say 2, just put the jump labels. All you have to do is leave one cell between the jump labels.
No, but it will be convenient when there is, if you want to introduce a parallel path. But if you want something in series like ammeter,
No, that is what I'm
That
saying.
time you need that room.
So I'll show you. You can show me. I'll show you one circuit and let's see how we can do. I mean, you can actually plot your voltage again. Let's check. We haven't seen the output.
Yeah.
No, something's wrong. So now what this means is your VAB is okay, your VBC and VCA both are wrong. So that means there is some problem between your B and C phase. Before, so let's check your circuit again and let's check first let's look at the inverter.
This is the load. First inverter.
So we had changed D6, right? So can you go to the simulator, go to the inverter parameters and export the parameters again so that we have the latest parameters.
Hi, Dada. You have to export this parameter.
Yeah.
Cannot create spreadsheet. Make sure file is
Oh, I think it is open. That is why. Okay. So I'm just checking. The biggest culprit is the polarity, which is okay. Yeah, the polarity now seems okay for all of them. So what we'll do, let us check the modulation signals which are output by the three phases. So let's say modulation signal of MA, MB, MC. Yeah.
This one.
Yeah.
Modulation 2.
Yeah. No, we can just plot the whole thing because usually modulation signal is just sine waves. Okay.
It is covered by that triangular wave. That's why I was first modified.
Oh no, just create a separate thing. I would say just create a separate one with just modulation signals.
all three phases?
Yeah, better. Make it A, B, C so that you can know. Okay, so your modulation signal is okay. Yeah, you have a balanced sine wave. Okay, so now the next thing we'll do, let us check your PWM code once. Code, control code. Okay, so triangle waveform modulation signal is sine 2 pi ft. Modulation signal 2, okay. So the first one is if X triangle is less than modulation signal 1, S1 logic is high, S2 logic is low. Otherwise, second one, S3 logic is high, S4 logic is low, otherwise it is the other way. Okay, come down now. And now we have S1 inverter gate, S2 inverter gate, S4, S5. The inverter logic is also okay. I don't see a problem. Okay, so now the next thing is, let us check out just show me the plot for the output voltage once. Let us try to debug. So the output voltage of VAB is correct. VBC and VCA are both wrong, right? So therefore, if VAB is correct, that means the switching of the first leg and the second leg are okay, right? So which means the third leg is what is the problem. If the third leg is the problem, then the difference between both VAC and VBC are wrong. That is what it means. So what we'll do once, let us go, okay, again open the control code and specifically look at the third one, the control code for this. And look only for, let's look specifically at S5, S6, S5 and S6. Okay, can you take me to the configuration of your control code in the circuit simulator? Let us make sure that these are defined correctly. You can go down and click on back. There is a down. If you go all the way down, yeah, back to main page. Now go to configure control. No, you have to go to edit control. In edit control, configure control. So now let's look at your output file, control outputs. So you see, you don't have S5 and S6.
Oh,
That's what's happening.
okay.
So you can add them and let's see. But most important is, this is how you debug. Like I said, right? We saw VAB is okay. So A and B are okay. VBC and VCA are gone. So which means there is a problem with third leg. No, initial value is 0. You can't, it has to be a number. It is just the initial flag. Yeah.
Which file? Folder one.
No, yeah, it's went above. Yeah.
So can we export it?
You can export. Yeah, you can just stop and run your simulation again. Okay.
And one more thing, that whenever we make some editing in the code, we have to just save it and it will be reflected in the Python Polytronic software. But whenever we change the schematics, we have to upload the file. So this is the difference I have observed.
Yeah, no, you don't have to upload the file. Once the file is there, then unless you add a new file, what you should do, you have to go to process circuit schematics and click on process circuit schematic. That's all. That's it. Because that way process circuit schematic will tell you if there is an error in the topology. Again, it will take some time. Actually, this tells me one other thing, that if there is a variable, of course the problem is that the output was not defined. So in this case, maybe I have to put a warning label saying that this variable doesn't exist. The problem is it's actually valid Python code. That is the problem. So, okay. It still seems like there is a problem. If you see, VBC and VCA are still there.
Whether I have used the same value.
Yeah, just check. Okay, can you do one thing? Can you go to the edit control and configure control. Check if you have declared static variables. Come down. You have declared S5, S6. Okay. So what has not been declared is which?
This name I have not chosen the correct one.
Ah, you put an underscore. That's why.
Yes.
Okay. Yeah, now it seems better. I think we can run once more, at least to see that it's symmetrical.
But still, the speed of the simulation, I'm thinking it is quite slow.
The speed of the simulation will be slow because it's Python as opposed to several others. So there will be like Python, because Python is a conversion to C. There is a multi-layer.
Even I was running in battery saver mode, that's why maybe.
Okay. But the main thing is, even if you connect several converters, the chances is it will run for several days, but your computer will never hang. That is the biggest advantage. With MATLAB, that's not the case. If you run MATLAB for several days, it will hang. Even for several hours, it will hang.
Yeah, I have observed, I have faced that.
I have run this Python simulation. I made a microgrid with 5 inverters. It ran for 4 days, but I got the output. It will never, that is the best part about Python, it won't crash because memory management is very good. Yeah, I think it just needs some time. So I think we are almost out of time. So unless somebody else has any doubt, I think we should slowly wind up. So anyway, so I think this, for those who are new, this is how we run this simulation code. Just bring whatever it is you need, whatever doubt you have, and we just try to solve it together. So I guess Nikhil is now reasonably, has been using it for a while. For those who are totally new to it, I guess either one, watch the YouTube videos, or you can start with simulations, bring it over, and we'll try to solve them. If you have any doubt, that is.
Yeah, sure,
And
sir.
it is converging.
Okay, very good.
Yeah, it is converging.
Okay.
And sir, maybe next circuit, maybe I was thinking, can we model a induction motor?
Yeah, whatever you want.
Take more time.
Whatever.
Not
I
in
mean,
form of equations, like actual physical model. Like
yeah,
from
it's,
power domain to magnetics, then magnetics to mechanical domain.
yeah, I mean, that's, like I said, it's like, it's totally driven by you. As long as, I would suggest that at least come up with something we can discuss. It may take several times. That's okay. Like it may take one session we can talk about the equations. Another session we can talk about actual coding, and maybe last we can talk about implementation. That's okay. So, but we can.
Because now inverter is ready. Inverter is ready. Now we can control using some control algorithms induction motor. So if we could model an induction motor and inverter is ready now, so if we could do some tests on induction motor, then it can be helpful for me as well as my friends.
Okay,
so
sure.
We all are from power electronics background, and we are working on induction motor, means control of motors and power electronics topology. So this would be a good thing.
Yeah, sure, no problem.
So how should, if we are targeting for induction motor, then how should we break this big project in small chunks, because it will not be able to complete in one session itself.
So first is, what I would suggest is next week you can think of what are the equations you want to write. Alright, so like for example, we talk about the equation, the model of the induction motor. So for example, what will be the equations? First we'll have to start with the current equation, that is the voltage divided by current, that is voltage, current, that is resistive drop, and EMF, right? Now the EMF is again is a function of the rate of change of flux, right? So now you have the flux. The flux is again an equation of the, what do you call, the current in the stator and the current in the rotor with respect to mutual inductance. So these equations we can then first come up with, and we'll talk about how we can write these equations in Python. So I don't know if you've taken my, say, transformer simulation course, but in transformer simulation course,
I have taken, but I have not completed it.
What I can suggest to you is just watch a few of the videos where I simulate a transformer. That will tell you how the basic magnetic model is. And then after that, or you can even look at the coupled inductor. That should give you an idea of how you use mutual inductance as self-inductance.
Yes.
And then once we have that, we can then use it for the induction motor as well.
The
Okay.
first task for the next week is I will look for the equations of induction motor for the stator part first. Then we will move to the magnetics and then the physical domain of the motor.
Basically, the entire motor will have to bring it together because it's an electromagnetic machine. So we have to map the output electrical versus the magnetic inside, and finally the mechanical. This will all have to come together in a motor. The only thing is, we'll have to see that, for example, again, it is like the basic KVL law will contain the induced EMF. Induced EMF is a function of the magnetic field. And the magnetic field in turn is dependent on the current in the rotor, which is dependent on the mechanical, like the torque and things like that. So this is how we kind of link all the variables together. So anyway, we can discuss. You think about it, we can discuss. No problem. Okay, so I guess we are done. Next week I won't be here. I'm going on vacation for 2 weeks. So next week and the week after will be a break. We will meet, I think, when will it be? We will meet on August 18th.
August 18th.
Yeah. Which is again a Tuesday.
Okay.
Okay. So anyway, thanks everyone for coming. See you in 3 weeks. Bye bye.
Okay, sir. Bye.